Hello, in this video we're going to learn about multiplying a polynomial by a binomial. But first I'm going to start you off with an old school multiplication problem. 3 times 21. We all know that if we were to do this problem, we'd either do it in our head or we would set it up like this. 21 times 3, and then we would do 3 times 1 equals 3, and then 3 times 2 is 6, so we know our answer is 63. Let me show you that another way. Imagine we had this box here, and I turned 21 into 20 plus 1, and then I had the 3 out here. And I multiplied 20 times 3 and got 60, and 3 times 1 and got 3, and then put them together and wrote 63. Some of you might be thinking this looks a lot like the distributive property, because it is. 3 times 20 plus 1 is 3 times 20, right, plus 3 times 1, 63. Well, the reason we didn't have to do it that way previously is because they're all numbers and we don't need to split 21 into 20 plus 1. But when we get to problems like 2 times x plus 3, we can't add x and 3, so we have to do the multiplication in a distributive property sort of way. And so we would multiply 2 times x and then 2 times 3, and we would get 2x plus 6. Well, algebra tiles are another handy way to illustrate what happens when you multiply a monomial, which is like this 2 here, to a binomial, which is the x plus 3. So let's show it. So if we had 2, and we can show that by 2 1s, so 1, 2, and then x plus 3, so x, and 1, 2, and 3. So now we have x plus 3 times 2. We can see that if we multiply the x times 1, we would get x. And if we multiply the x times the second one here, we would get another x. And now if we multiply this one times this one, let me mark that in red here, this one times this one, we would get a 1. 1 times 1 is 1. And this second one here times 1 is 1, and so on. And then we get to this, the one down here on the left, bottom left. So that one times all 3 of these 1s. And you can see that we get a nice rectangle here with the x's here and the 1s here. Remember, when you're doing multiplication, a model for that is area of a rectangle, and that's what we have here. And notice what we have. We have 2 x's. Let me outline the answer here in green because there was that black border there. So we have the 2x plus 6, right? 1, 2 x's, and then 1, 2, 3, 4, 5, 6, which is the answer. So algebra tiles are a great way to model the distributive property and multiplication of monomials and polynomials. Unfortunately, there are some limitations to algebra tiles, as you can see right here. We don't have an algebra tile for x to the 4th, and so we can't always do everything with algebra tiles, but we can still use the distributive property here. So we just want to multiply 3 times everything, every term inside these parentheses, and we got one more here, bam. So that 3 is going to multiply to x to the 4th and get 3x to the 4th, right? 3 times x to the 4th, plus 3 times x to the 3rd, plus 3 times 2x squared. Well, 3 times 2 is 6, and then times x squared, we just write like this next to it. And then 3 times 6x would be 18x, and finally 3 times negative 5 would be negative 15. So that's how you would do that problem. So let's get to something a little more complicated. And you might be thinking, well, my gosh, there's an x squared out here and a 4, and then there's a bunch of x's in here. What am I going to do? So before we get to that, let's just skip it, and we'll get back to that later. And we'll skip it by looking at a problem that looks possibly even more complicated. So we have 3a cubed b squared times negative 5a squared b to the 4th. So the question is, how do we multiply all this together? Well, the first thing I think to keep in mind is every single one of these things is multiplication. These parentheses mean multiplication. The 3 next to the a means multiplication. This a cubed is just a way of saying a times a times a. So all we have here is a bunch of multiplication. And so if we split it up, 3 times a times a times a times b times b times negative 5 times a times a times b times b, oh, I ran out of room, times b, this might be a lot easier. Well, let me show you something over here before we get too crazy. We all know that 2 times 3 times 4 is 24 because 6 times 4 is 24. Well, isn't it also true if we did like 3 times 2 times 4, that would also equal 24? 6 times 4 is 24. Or we could also do like, ooh, I moved that all the way over there. Look at that. So we could also do like, could have the 3 down here and the 2 down here, and could mix this over to here and put this here. So with multiplication, we find that it doesn't matter what order the numbers are in, as long as we're multiplying everything, we'll still get the same answer. So if that's true, we should be able to reorder all of these things. And so if I want to multiply that 3 times negative 5, well, that's real easy. I can do that right here. And then 1, 2, 3, 4, 5. If I'm going to multiply 5 a's together, I could just put those together. And then if I want to, I have 1, 2, 3, 4, 5, 6 b's, so I'll just put those all together. 3, 4, 5, and 6. And now I'll just squeeze it back together. So 3 times negative 5 is negative 15. A times A times A times A times A, well, the pro-style fancy way of doing that is just writing A to the 5th. And then B times B times B times B times B times B is just like writing B to the 6th. So voila. To multiply these two monomials, I can just spread them all apart and then push them all back together again after I reorder them. I call that the accordion method because it's similar to playing the accordion. Here's my little accordion here, and you can hear the music as you spread it apart, push it back together. So when you are playing the accordion, spreading it apart looks kind of like this, and then when you push it all back together, you get your final answer. Alright, so now let's try this problem that we had looked at earlier and see if we can do it. So we're going to multiply this because we have this number outside, this monomial, multiplying to this polynomial here. And so this 4x needs to be multiplied to every single item, every single term. So we have 4x squared times 7x to the 3rd, and then we need to do 4x squared times 2x squared, and then we need to do 4x squared times negative 6x, and then we need to do 4x squared times negative 4. So as you can see, 4x squared is going to multiply to 1, 2, 3, 4, all those terms. Okay. Now, if you remember from the last slide, the accordion method tells us that we can split all these things apart and put them with the things or the letters or the numbers that they go with. So we can do the 4 times 7 first, giving us 28. And if we have 2 x's here multiplied to 3 x's here, that's a total of 5 x's. So that's x to the 5th. So we're done with that multiplication. Now we get to this plus sign. 4 times 2 is 8. We have 2 x's here and 2 x's here. That's 4 x's being multiplied together. Over here we have 4 times negative 6. So instead of putting plus here, I'm going to put a minus. So that's 24, right? 6 times 4 is 24. And a negative times positive is a negative or a minus. We have 2 x's here and 1 here. So 3 x's being multiplied together is x cubed. And then again we have a 4 times a negative 4, so instead of writing plus here I'm going to write minus 16, and then x squared, 2x is being multiplied together, looks like that. Now we're going to squeeze it back together using the end of the accordion method, and we have our final answer. Actually, it was already squeezed together, it just looks spread out up top, so I just rewrote it closer together. Alright, so getting back to the multiplying letters that have exponents, let's take a closer look at that. If I have x squared, that just means two x's multiplied together, and then x cubed is like this. So notice x times x times x times x times x really just means x to the fifth. Now we get to the c's down here. We have c times c times c, that's those three, times c times c times c times c, that's those four. So it looks like we have 1, 2, 3, 4, 5, 6, 7 c's multiplied together. That's how we write that. And then we have 2 v's multiplied, and then 5 more v's. And so we end up with 1, 2, 3, 4, 5, 6, 7. So if you look at each of these individually, and you look at the powers here being multiplied, and the final answer, just the power that I'm circling, what do you notice in each of these problems? A 2, a 3, and you get 5. Here we have a 3 and a 4, and you get 7. Here you have a 2 and a 5, and you get 7. What do you think you can do with these exponents rather than writing it all out each time? Any thoughts? Here's something to think about. See if you know what the answer to this is. Q to the 10th times Q to the 28th. So obviously you wouldn't want to write that all out. Can you tell by looking at these previous three examples what the answer would be? If you said Q equals, or sorry, not equals, but Q to the 38th power, you'd be correct, because you're just adding the powers together. Okay, not to be confused with adding the coefficients together, which are these numbers here. Notice we don't add them, we don't get 11, we multiply them, we get 28. Okay. Alright, thanks for watching the video.